electricity. The study of effects of charges at rest or motion. Study of effects of charges at rest or motion. The charges at rest. What type of fields can be produced by them? It's a electric field or magnetic field. Electromagnetic field. Okay. If the charges are at rest, if the charges are in motion, for example, if you take about diodes, okay, p-n junction diode, okay, capacitor, and next one transistors. Charges are at rest. Only when they are at rest they can create some effects. Okay, so due to that effects the appliances can be run. Next one, charges are in motion. House wiring. Okay, so the charges will be, they are moving from pole to meter to different appliances in the house. Okay, charges are in motion. So the study of effects of charges at rest or motion is called what? Electricity. Okay, so first one, the study of effects of charges at rest or motion. At rest or motion is called electricity. Is a electricity. Okay, so this is about electricity. For the study of effects of charges at rest or motion. If the charges are at rest, if the charges are at rest, if the charges are at motion, they are in motion. So if charges are at rest means what? If I talk about rest condition, rest means study of effects of charges at rest. The study of effects of charges study of effects of charges at rest is called electrostatics. Okay, so this is at rest condition. I'm talking on this is the rest. Next one, when you're talking about the motion of the charge, it's a motion. The study of effects of charges okay, charges in a motion, when they are in motion, is electric current. That's what current electricity. Study of effects of charges at motion is called current electricity. What is electrostatics? Electro means charge, statics means rest. Electro, okay, electro plus statics is equal to electrostatics. Electro means it's a charge. Statics means it's a rest. This is electrostatics. Study of effects of charges at rest. So, next one, what is charge? What is charge? Charge is an intrinsic property. Charge is a quantized matter. Okay, so it's what? It is a fundamental unit fundamental unit in electricity. Without this, we cannot discuss anything. Fundamental unit in electricity. Okay, so and the charge is what? It is a quantized property. It is a quantized property. Quantized property which flows or which moves, which flows from higher potential to lower potential point. This is charge. When a charge is at rest, when a charge is in motion, so the charge is what? It is a fundamental unit of electricity. Is the fundamental unit of electricity. So it's a quantized property. What does it mean by the term quantized property? Quantized property means what? It's a integral multiple. I'll show that. So just it is a quantized property which flows from higher potential to lower potential point is the charge. So charge is denoted by, it's a Q. Charge is what? It's a Q. Charges are two types. One is positive charge. Next one is negative charge. Positive charge and negative charge. Positive charge is called higher potential charge. Higher potential. Okay. Next one. This is what? Lower potential. It's a higher potential point, higher potential charge. So this is what? It's a lower potential one. So charges. So first one, what do you think about if the charge is at rest, if the charge is in motion, if the charge is moving with a uniform velocity, if the charge is moving with a accelerated motion. So does it produce electric field or magnetic field? Otherwise electromagnetic fields. Okay. So now the question is about how does it's a question like, but put the siding like. Okay. How does charge produce or experience? How does charge produce or experience electric and magnetic fields? Electric and magnetic fields is my question. The charge is at rest. It only produces electric field. The charge, this is the charge, it's a Q. If the charge is at rest, okay, so this is what? It's a charge, either positive or negative charge. If the charge is at rest, it can produce only what field? Electric field. It can produce only electric field. Electric field is what? It's a E bar. Okay. And if the charge is in uniform motion, it produces electric field and magnetic field. So uniform motion means what? Charge is at rest. Here is what? It's a charge. This is what? It's a Q. Okay. If I talk it as, it's a uniform motion. It's a uniform motion, right? So this is what? Here is a charge Q. This is uniform motion. Charge is at uniform motion. If it is at the uniform motion, it produces, okay, it produces electric field, it's a E bar, and magnetic field, it's a B bar. Magnetic field, it's a B bar. So if the charge is in uniform motion, it produces electric field and magnetic field. If the charge is in non-uniform motion, so if the charge is in what? Non-uniform motion, if the charge, it's what? Q, okay, like its velocity is varying, this is what I can say this, it's a non-uniform motion. It's a non-uniform motion. Non-uniform motion means what? Accelerating. What is its acceleration? 0. Because it is moving with a constant velocity. So uniform velocity, uniform motion. If it is a non-uniform motion, means what? Accelerating. Okay. It produces electric field and magnetic field. Electric field and magnetic field. And also electromagnetic wave. It also produces electromagnetic wave. Okay. So this is electromagnetic wave. It also produces electromagnetic waves. These are the conditions when charge is at rest. Okay, it only produces electric field and no magnetic field. If the charge is with a uniform motion, it produces electric field E and magnetic field B. The charge is in non-uniform motion, it produces electric field E, magnetic field B, and also it produces electromagnetic wave. So, and also it produces electromagnetic wave. Electromagnetic wave producing means what? It radiates. Okay, it radiates like. Okay, so next one here. What about the unit of charge? What is charge? What is the unit of charge? So, if you talk about what about unit of charge? Okay, charge is what? It's a Q. It's a Q. Yes, sometimes we can represent capital Q or small q. No issue on this. It's a charge. It is measured in what are the units of this? The units of charge is what? Units of charge is coulomb. It's a coulomb. It's what? C. Okay. So charge is measured in coulomb. So that is what? In a SI system. And this is what in a SI system. So just for understanding, it's a stat. S-T-A-T. Stat coulomb. Okay. Stat coulomb. So it's what? In CGS system, like we can represent. What is the dimensional formula? Dimensional formula of charge. Okay, dimension formula. It comes from where? Current. Dimension formula is what? The powers of fundamental physical quantities. So electric current is one of the fundamental physical quantities. Then what? I is equals to Q by T. Then Q is equals to IT. Dimension formula of Q is equals to dimension formula of IT. I, it's a T is the thing. RTI. It's a dimensional formula. Okay. So like you can represent on this. Now here Q is equals to I into T, or sometimes we can also write AT. A stands for ampere. It's a AT. It's a AT. Yes. And what is the nature of charge? Its nature is what? Charge is, it's a scalar quantity. Scalar quantity. Scalar quantity, it's a directly, it can be added. Directly added. Okay. Scalar quantity means what? If we have the charges, for example, so some Q1 is equals to 2 coulomb, Q2 is equals to 6 coulomb, Q3 is equals to minus 4 coulomb, like. So what is the net charge? Directly we can add them. Then Q net is equals to, we can write Q1 means what? 2 coulomb plus 6 coulomb minus 4 coulomb. Okay. 6 plus 2, 8. 8 minus 4, 4. It's a 4 coulomb is the answer. Are you following any methods like I cap, J cap and K cap? No, because it's a scalar. Scalar has only magnitude but no direction. Okay. Scalar means what? Only magnitude. Only magnitude. Okay. So, but no direction. But no direction. It has only magnitude but no direction. So, this is about, yeah, charge is a scalar quantity. Next one, the charges, what are the properties of the charges means, it's a basic information. Charges, they can, like charges can be repelled, unlike charges can be attracted. Okay. So, next one is about properties of charges, means, for example, if I choose it, their charge should not be held by your hand, because hand is one of the conductors. The charge can be transferred through your hand. Okay. So, just it is suspended. I am taking as 2 charges. Yeah, 2 charges, right. So, it's what? Plus positive charge, negative charge. Okay. Next one, here, same the thing. Next, so this is what? It's a negative charge and positive charge, like. Okay. So, these two are what you say, it's a unlike charges. Unlike charges means what? Attracted towards with each other. With the same force, they can be attracted. Okay. So, from these I can talk on this. Unlike charges can be attracted towards each other, towards with each other. Okay. So, this is about unlike charges. If we talk about now the charges, for example, this here, one charge is here, it's a plus Q. Next one is about, again, same plus Q only taken. Next, after this, here, this is minus. Okay. It's a minus Q. Next, another one is minus Q. So, these are the like charges. Like charges are repelled with the same force. Okay. So, they are repelled like this. So, we can make it as unlike like charges. These are unlike charges. Here, like charges are repelled with each other. Okay. So, they repelled with each other. Now, next one, do you think the charge can be transferable? Okay, charge can be transferable. So, first one, is the charge is transferable or not? Okay, charge is transferable or not? So charge is transferable. Transferable means it can be transferred from one body to another body. When for example, when two bodies are in contact, when two bodies are in contact, okay, the charge can be transferred. The charge can be transferred. Yes, it can be transferred from one body to another body. From one body to another body. Yes, it can be transferred from one body to another. Till to get the equilibrium charge. For example, one has 8 microcoulomb, next one is 2 microcoulomb. When you made to bring in contact, what happened? Charge can be transferred from 8 to 2. Okay, 8 plus 2 is what? 10. So both should be equally, what is that? Sharing. That's what you say, 5 and 5. Till to get both the bodies have the 5 microcoulomb and 5 microcoulomb, so the charge can be transferred. Okay, so if the charge is transferred or not means what? Yes, transferred. Next one here, do you think so? Is okay? Otherwise, does the charge contain? Does the charge contain mass? Okay, so the charge, positive charge if I say, negative charge if I say this one. So do you think the charge contain mass? Yes. So in the presence of charge itself, so then what? It has the mass. Okay. If the charge is, for example, if the when a body loses electrons, what is the charge of electron? So what is the charge of electron? Electron charge is, what you say, it's a 1.6 into 10 to the power of minus 19. So that's what? It's a coulomb. Yes, it's a coulomb. Yes. So this is the charge of electron. Yes. Now one body loses the electrons. One body loses the electrons. Another body gains the electrons. If the body loses the electrons, what type of charge can be remained? So it's a positive charge. Okay. So just I can say you that when a body loses, the electrons, it acquires positive charge. Which charge is this? It's a positive charge. It's a positive charge. Okay. So when a body so gains the electrons, then what? It has negative charge. Okay, it has negative charge. What is the quantization of charge? Such a very important thing. What is the quantization of charge? Okay, so that's what? Quantization of a charge. Okay, quantization of a charge. What do you mean by the quantization of charge? Quantization means integral multiple of charge of electron. Integral multiple, that's what? Okay, integral multiple of charge of electron is called quantization. It's a quantization. Just you remember. What do you mean by integral multiple of charge of electron? I am giving an example. There is a body is taken. Yes. Its charge is what? It's a Q. For example, Q. How many electrons? Q is equals to, if I say 2000 electrons, 2000 electrons. Okay. So the charge has, okay. So for example, 9 into 10 to the power of 6 electrons. If the charge, this body has how many electrons? Okay, 1.9 electrons. But the body contains 2000 electrons is right thing. Yes, 2000 electrons. 9 into 10 power 6 electrons. Yes, but 1.9 electrons what? 1 electron there, 2 electron there, 20 electrons there, 1000 electrons are there. 20,000 electrons are there, 90,000 electrons are there, like. But how the number of electrons can be expressed in 1.9? It's not possible. Yes, this is not possible. So that's what I'm saying. How many electrons? The body has how many electrons? Q is equals to plus or minus Ne. Sir, it may has. So 6 electrons there. Yes, correct. 1.1 electron. 1.1 electron is what? Either 1 electron or 2 electron. 1.1 electron is what? It's a meaningless. So that's what you say. Here Q is equals to plus or minus Ne. Okay. E is what? Charge of electron. Then what do you say? You got the point now from here. Is it okay? So I can say you this. Q is equals to plus Ne. Q is equals to minus Ne. If a body has Q is equals to plus Ne, plus means what? Positive charge. Positive charge means it's a loss of electron or gain of electron. Loss of electrons. Okay. So this is what? It's a loss of electrons. Loss of electrons. It's a gain of electrons. Gain of electrons. Okay. Loss of electrons or gain of electrons. Like. So this is now how can you define this quantization of charge? It is an integral multiple of charge of an electron is called what you say? It's a quantization of charge. Integral multiple of charge of an electron is called quantization of charge. So it's a quantized property. It's what? N is what? It's an integer. N is the integer. Okay. So this is what? Quantization of charge. But just I'm taking an example for this. So the question is what? 1 coulomb charge. 1 coulomb charge has, okay, has dash number of electrons. 1 coulomb charge has dash number of electrons. How many number of electrons? So 1 coulomb charge is what? Q is equals to what the condition? Ne. If you write positive, it lost the electrons or gained the electrons? Lost the electron. If you write minus, gained the electrons. Q is equals to Ne. It's a Q is equals to Ne. Q means 1 coulomb charge, he said. It means Q is equals to 1 coulomb. Yes. And E is equals to 1.6 into 10 to the power of minus 19. Okay. So 1 coulomb charge. What is the value of this one? E? 1 coulomb, right? So it's a 1.6 into 10 power minus 19. It's a charge. It's not this, sir, you are taking about 1.6. No. Number of electrons, how many? How many number of students are there in the class? 2 students, 20 students, 40 students, 30.4 students. Meaningless, correct? So like that I am talking about quantization. How many electrons are there? 1 electron, 2 electron, 1.1 electron, wrong. But electron charge is what? 1.6 into 10 to the power of minus 19. Okay. So then what is the Q? 1 is equals to, it's a N only. E 1.6 into 10 power minus 19. N is equals to 1 by 1.6 into 10 power minus 19. N is equals to 1 by 1.6 10 power 19. N is equals to 1 by 1.6 is what? 0.625. Simplify that. 0.625 into 10 power 19. It's a 6.25 into 10 power 18 number of electrons are there. 1 coulomb charge has 6.25 into 10 power 18. So after this number 18 zeros. Okay. So these many electrons are there. Charging. Okay. Of a body. Very important thing. Charging of a body. Charging, I can also say it's a electrification. What is charging? What is charging? Charging is what? When two bodies are in contact. When two bodies are nearby with each other. One is neutral body, another one is charged body. When two bodies are rubbed together, glass rod and silk cloth, one body can lose an electron, another body can gain the electrons. The process of transfer of electrons from surface of one body to surface of one body to another body is called charging. Okay, so this is called, what is a charging? It's a charging. Is also called electrification. What are the methods of charging? Such a very important thing. Methods of charging. Okay, so first one I'm talking about, it's a methods of charging. Methods of charging. Yes, methods of charging. Okay, so for the methods of charging, first one I'm talking about here, method of, so that's what, charging of a body by electrification or charging by friction. First one is what? Charging by friction. By friction. By friction means rubbing. Charging by friction means it's a charging by rubbing. Okay, so this is what, it's a rubbing. It's a rubbing. Yes, so charging by friction. Second one is about charging by conduction. It's a conduction. Third one is charging by induction. Charging by conduction and charging by induction. So these are the cases. First one, methods of charging of a body is a charging by friction, that's what, rubbing, and charging by conduction and charging by, it's a induction. So what is the charging by a friction? When one body is rubbed with another body. When one body is rubbed with another body. So here charging by friction. Charging by friction. Charging by friction is also, we can say, what is this? It's a rubbing. This is rubbing. So charging by friction and charging by rubbing, it means when two bodies, generally conductors and insulators. Conductors and insulators, this is applicable for the both conductors and insulators. Before that, what do you mean by conductor? Which has free flow of charges. What are the charges? Electrons. Okay? Electrons. Free flow of electrons. Which is good conductor of electricity. If you take about insulator, which has no free flow of charges. Okay? So charging by friction. Friction, when one body is rubbed, when one body is rubbed with another body, if one body is rubbed with another body, okay, then what do you say? Here charges can be transferred. Charges can be transferred. So this is charges are transferred from one body to another body. So for example, I am taking on this very first one. Glass rod is rubbed with silk cloth. Silk cloth. Not only glass rod and silk cloth. First let me know on this one. Glass rod has ability to lose the electrons. Silk cloth has ability to gain the electrons. Then glass rod it acquires positive charge after the rub. So after the rubbing, the charges are transferred from here to here. So this is what? It's a silk cloth. It's a cloth. Okay. So this is what? It's a glass rod. It loses the electrons, then it gains the electrons. When electrons are gained, so what charge is this? It acquires what? Negative charge. So this acquires what you say? It's a positive charge. It's a positive charge. And next one, this is what? It's a negative charge. It's a positive and negative charge. Not only this, many examples. When a new pen is rubbed to your dry hair, okay, so now your hair, it has ability to lose the electrons, and so new comb or what is that? It's a pen or plastic. It gains the electrons. So one has positive charge, next one has negative charge. So they will become what? First individually. So those are they have no charges. Means what? Electrically neutral. When they are rubbed together, one acquires positive charge, next one is what? Negative charge. Okay. So next second one I am talking about. So one more, many examples we can say. Silk cloth. Okay. Next one is a glass rod. And a pen means combing to what? Dry hair. Okay. Next one, cat skin, ebonite rod. Many examples. Okay. So just this is the best one. And second one is about, so what is this? Charging by conduction. Charging by conduction. But charging by conduction, what's the meaning of exactly the meaning of the conduction? First I am taking about there is a charged body. This is another charged body. One is neutral, next one is charged. Whatever, no issue on this. And its charge is distributed on this. This is the charge. It's what? It's a Q. Let it be, it's a Q1. Okay. So next one, this one also has some charge on this, or any charge, some amount, the magnitude of charge may be different. Yes, I have a wire like. Are these two wires are connected? No. Not connected means what? The charge on this one is Q1, next one is what? It's a Q2. When these two bodies, okay, now the same bodies are here, they are connected. Okay. So when wires are connected, it acquires the charge. The new charge will be, it may lose some amount of charge or gain some amount of charge, whatever that, till to maintain equal potential. When two bodies are connected, when two bodies, which bodies are these? Charged bodies. When two charged bodies are connected, when two charged bodies are connected, potentials are equal. Potentials, okay, are equal. Yes is my condition. Means what? V1 is equals to V2. Okay. So the potentials of equal means what you say? It's a V1 must be is equals to what? V2. Till to get the equal potential, charges can be transferred from higher potential to lower potential. So now I'm choosing about, here is the charged body. Next one is this. Okay. Its charge is Q1. Next one is Q2. Okay. So both are made in contact. It means what? Connected means what? Both are made in contact. This will become as what? Q1 plus Q2. Total charge is what? Q1 plus Q2. Next one, it would be again separating. So after the separation, the charges are what you say? It's a Q1 plus Q2 by 2 and Q1 plus Q2 by 2, like this. Okay. So charges, what the charge? For example, if I'm taking about 10 microcoulomb charge, this body has 10 microcoulomb charge. This one has 2 microcoulomb charge. Now it will be what? 12 microcoulomb charge. So this will be, so equally should be divided 6 microcoulomb, and next one is what? It's a 6 microcoulomb charge. Okay. Q1, Q2. This will be Q1 dash and Q2 dash after getting what? Equal potentials. Okay. So next one, and another case I'm talking on this. So what is this? Electrification. That's what? Charging by what? Induction. Okay. Charging by induction. Now very careful on this induction process. So what is the induction process? Charging by induction. So if a charged body is brought nearer to the neutral body, okay, from this case charged body, okay, charged body is brought near to neutral body. So it's a neutral body. What happens? Some amount of charge will be induced on this. The amount of charge is induced here. First one, I'm taking as 3 different situations. This is the body. Okay. So here is what? Charged body. It's what? Neutral. This one is what? First, one you can say as a neutral body. Neutral body means what? Better I'm talking on this. It's a uncharged body, like this. I'm talking this. Okay. So it's a uncharged body. Okay. Uncharged. Next one is, this one has positive charge. Let it be, it's a positive charge. Listen. So it's a charged one. This is what is it? It's a charged one. Now come to the point from these two situations. First one, uncharged body means what? Uncharged body means what? It's what? Electrically neutral. Electrically neutral means what? Does it has electrons? Yes. Positive charges? Yes. Negative charges? Yes. Means what? The number of positive and negative charges are equal. Electrically neutral. Okay. So when you bring this positive charge nearer to the uncharged body, whichever the positive charges are there inside of this, they will be repelled by it. Positive charges are in this inside of this, so they will be repelled by this positive charge, because you are bringing the positive charge nearer to this. Then what happen? Remaining electrons means what? Negative charges will be attracted towards this. It means here these are the negative charges attracted towards this. These will be positive charges. Okay, are repelled. Okay, so this thing will be happen. And next one, in the same second situation, this is what? Same diagram I'm drawing this. Here is a sphere. which is connected to the earth, which means what? Earthen. Yes. So already I'm not disturbing the situation. This everything is same, but just earthen. So this is what? It's a negative charge. Correct? It's a negative charge. Positive charge is what? Connected to the earth. Okay. Then next one, again the situation here. This is what? So next, what is that? It's a negative charge. Yes, some charge is induced on this. This is some charge is induced. This is what? Removed one. First condition. Okay. Next one, second condition. Next one, third condition. This is what? Earthen. Okay. So earthen case. Potential is equals to 0. Okay. In this case is what? The earthen is removed. Some amount of charge is induced on this body. What is this? Q dash. What was the actual charge here? Q. Okay. So this is called what? Charging by induction. Such a very important case. Charging by induction is what? Whenever charged body brought to the uncharged body. Okay. So in uncharged body, whatever the like charges are there, they are repelled, will induces to the opposite side, and which are like charges means opposite side, unlike charges will be towards to that. Then when it is earthen, so this some amount of charge induced on this, and if you remove this one, the induced charge is what? This is what? It's a induced charge. Induced charge is Q dash is equals to Q times of 1 minus 1 by K. Just you remember, later you will discuss. So Q dash is equals to Q times of 1 minus 1 by K. K is called what? Dielectric constant. Okay. So where K is called dielectric constant. Okay. So this is K is dielectric constant. So dielectric constant means what? For better understanding, you also can write it as epsilon R. What is this? Epsilon R. Epsilon R is what? Relative permittivity. Relative permittivity. So is what you say? It's a relative permittivity. Yes. So K and epsilon R both are same. Okay. So now this is what? Charging by induction process. So can you answer for this? Now first case, second case, third case. First case is what? Charged body is brought nearer to the uncharged body. Okay. Next one is about charged body is there but it is connected, then positive charges are enter into this one. Okay. Next one is what? Then the earthen part is removed, then it has a negative charge. Its potential become as what? Negative. Potential become as what? Negative. Okay. So now if you remove this portion, which one? Charged body is removed from this. When charged body is removed from this, what happens? Only negative charge is there. No, this negative charge is accumulated over this one. Total the body. Getting my point? Okay. Total the body it will be accumulated. Okay. So this part if you remove, then only this whatever the negative part is there. So the total charge is what you say? It's a accumulated. Means as a fourth case we can say here. This is what? Negative charge is accumulated, okay, over the body. So this is what? Induced charge. Yes, I can write it as it's a induced charge. Okay, induced charge. When the induced charge is here, whenever, so charged body is removed. Charged body is removed. Okay. So is the situation. This is about charging and method of charging, like we can say the methods of charging. So conduction, induction, next Next concept, Coulomb's law. Coulomb's law. Yes, what is Coulomb's law for the problem solving? Yes, so Coulomb's law, the electrostatic force. Coulomb's law is what? If I choose about two charges. Yes, these are the two charges. Its charge is Q1. Next one is what? Q2. Yes. First one, line joining of their centers. Line joining of their centers. This is the line joining of their centers. Yes. They may be attracted or repelled. They may be attracted or repelled. Okay. So this distance is what it say R. Yes. Now the force of attraction. Attraction means what? Towards this. Repulsion means what it say? Away from this. Attraction means negative charge. Repulsion is what it say? Positive charge. Okay. So if I have this Q1 and Q2, these are the force is what it say F. This first charge and this one is the second charge. Second is acting on first one. Then what is it? 2 on 1. Force acting second charge on first charge. Okay. Vectorially. Next one. Force acting. Okay. That's what? First charge. Okay. First charge on second charge. Vectorially. Yes. Force acted by first one on second. Force acted by second one on first one. Like this. If it is, they are like charges. If they are unlike charges, will be attractive. Okay. So now the first condition, electrostatic force, a force of attraction or repulsion directly proportional to product of magnitudes of charges. Product of magnitudes of charges. And electrostatic force is inversely proportional to distance of separation of two charges. So from these two cases, then what do you say? F is proportional to Q1 Q2 by R square. F is equals to some K into Q1 Q2 by R square. F is equals to 1 by 4 pi epsilon naught Q1 Q2 by R square. This is what? Electrostatic force. Electrostatic force. So do you have any vectorial representation on this? No. Only force, its magnitude. Okay. So now just let me know on this one. First one, what is the epsilon naught? Epsilon is permittivity. So this is what? Permittivity. Permittivity of medium. Epsilon is what is it? It's a permittivity of medium. So epsilon naught is the permittivity of free space. What do you mean by permittivity? What do you mean by permittivity? Permittivity is the ability of medium or ability of the substance to allow electric lines of force to pass through it. Okay. So here the permittivity of a medium is what is it say? For the medium is epsilon. It changes from medium to medium. And epsilon naught is what is it say? Permittivity. So this is permittivity of free space. It's a free space. Next one, epsilon R is what you say? Relative permittivity. So relative permittivity. Yes. So this is what relative permittivity. Do you know epsilon R is equals to epsilon by epsilon naught? Yes. So this is equals to what? K. K stands for what? Dielectric constant, which we discussed earlier. So it's what? Dielectric constant. Here 1 by 4 pi epsilon naught we have. Its value is 9 into 10 power 9. F is equals to, so 1 by 4 pi epsilon naught. K is the constant. In place of K, what to write? 9 into 10 power 9. Q1 Q2 by R square. Okay. So Coulomb's law. How do you state the Coulomb's law, or what is the exact statement? So the electrostatic force is directly proportional to product of magnitudes of two charges, inversely proportional to square of distance of separation acts along with the line joining of their centers is, what do you say, it's a Coulomb's law. Okay, so from the Coulomb's law, it is applicable for the point charges. Okay, very important case. So Coulomb's law, it's what is it for the point charges? Point charges means what? So you have a bigger charge, you know. Yes. So first one, it is applicable. It is applicable. So applicable. So for point charges. Point charges. Well, point charges means this is what one charge, here is the next charge. It's a Q1 and Q2. Distance of separation is what? This. What is this? It's a R. Yes. So now I can write it as F is equals to 1 by 4 pi epsilon naught Q1 Q2 by what? R square. So if I have a bigger spheres, bigger bodies are there, then how do you take it as? Its total charge is, so I'm taking as this is what? It's a C1 and it's a C2. So this is what as the point charges are. What are the point charges for me? It's a Q1 and Q2. Okay, in my view, so this is my point charge. Yes, so then what do you say? Again the distance is what? It's a R from their centers. What do you write? F is equals to 1 by 4 pi epsilon naught Q1 Q2 by what? It's a R square. Okay, it's a point sized bodies. Yes, next one. Here, next one is about, for example, if two charges are there, okay, so two charges, for the next condition is what? What is this? F is equals to 1 by 4 pi epsilon naught Q1 Q2 by R square. So first my question is about, if Q1 and Q2 are doubled, Q1 and Q2 are doubled, what will be the force? Our distance of the two charges is increased, double, triple, 4 times. Distance of two charges is decreased. Yes. So next one is about, if the two charges are kept in the air, two charges are kept in the water, medium. Medium has its permittivity is different. Na? Yes. So first condition I'm talking on this. Yeah, very first situation. This is what? When two charges means, first of all charges are here. When distance between two charges, distance between two charges is doubled. Okay, so it's a doubled. So doubled means what? R1 must be R, R2 must be what? It's a 2R. So then what? F is equals to 1 by 4 pi epsilon naught Q1 Q2 by what? R square. F is inversely proportional to R square. So then what do you write from this case? F1 by F2 is equals to R2 square by R1 square. Sir, I taken double. You may make it as halved. Okay, half. Yes. So like F1 is what? F. This is what? F2. R1 is what? R square. R2 means what? 2R whole square. So F by F2 is equals to R square by what you say? It's a 4R square. These two will be cancelled. Then what is this? F2 is equals to F by 4. It's a common sense, just a common thing. Means, sir, when distance is increased, force of attraction or repulsion increases or decreases? So decreases. How many times? 1 by 4 times. Okay. So 4 times decreases. So like one first model is what? Like we can say, what is this? When the distance between the two charges is doubled. And for the second, if we talk about second. The second one is such a very important thing. Two charges are kept in the medium. What is the new electrostatic force of attraction or repulsion? I'm changing my question. Two masses, gravitational force. Two masses are kept in the medium. What is the gravitational force? Nothing. Universal gravitational constant is what? Same. G value is what? Same everywhere. But epsilon value changes from medium to medium. Okay. So effect of medium. It's what? Effect of medium. This is what? Effect of medium. Effect of medium is what? So for example, F in the air, if I keep it as in the air, is equals to what you say? 1 by 4 pi epsilon naught q1 q2 by what? R square is my first relation. In the medium, if we talk about, it's a medium 1 by 4 pi epsilon, not epsilon naught, it's a epsilon, permittivity of medium, okay, into what is this? Q1 q2 by what? It's a R square is my second situation. Now from this you can take it as, so just F air by this two will be cancelled. It become as what? Epsilon by epsilon naught. Okay. F air by F, what is this? Medium. Epsilon by epsilon naught. Correct? So this we can take on this. Here, this F medium is equals to, F medium is equals to, do you know epsilon by epsilon naught? Epsilon by epsilon naught, 1 by 4 pi epsilon naught, 1 by 4 pi epsilon. It is, so epsilon by epsilon naught. Earlier case we discussed. It's a epsilon r. Epsilon r means what? K. K. Okay. It's what? K. This is what? It's a K. So F medium is equals to F air by what? It's a K. Means what? K times decreases. Okay. If it is kept in the, so first one is what? In air. Next one is what? In a medium. Okay. So in place of this one, F medium is equals to 1 by 4 pi epsilon q1 q2 by R square. In place of epsilon, what to write? K into epsilon naught. Means what happens? It decreases by how many times? K times. Next most important concept, superposition principle. Very important, superposition principle. Superposition principle means what? If you have only two charges, electrostatic force q1 q2 by R square, I have three charges, many charges, infinite charges. Okay, so what is the electrostatic force between them? Okay, so that's what. Next one is what you say? It's a superposition principle. Superposition principle. So what is the superposition principle? It's a nothing, just algebraic, the total force is equals to algebraic sum of all the forces. Algebraic sum of means the net force is equals to algebraic sum of, or that's what, vector sum of, better. So it's what? Vector sum of all the forces. So this is vector sum of all forces. Okay. It means F bar is equals to F1 bar plus F2 bar plus F3 bar plus so on, like this. How many are there? Those we can use it. For example, if you have this, for example, I'm using as like a coordinate system. Okay, it's a x and y axis. So there are my charges 1, 2, 3 and 4. Like these are the charges. So it's what? This is what? It's a q1, q2, q3, q4. Here some charge is there. Let it be. It's a q naught. Let it be. It's a q naught. What are the relative distances? Relative distances r1. This is what? R2. Next one is what? R3. Okay. Next one is what? R4. My question is what? So net force on Q naught. Net force on Q naught. With Q naught, how many charges you have? 1, 2, 3, 4. 4 pairs are there. How many possibilities are there? F bar is equals to F1 bar plus F2 bar plus F3 bar plus F4 bar. Okay. So F1 bar, F1 means what? 1 by 4 pi epsilon naught Q1 Q naught by R1 square. For this Q1 Q naught by R1 square. Next one is what? Q2 Q naught by R2 square. Q3 Q naught by R3 square. Okay. So next one, F2 I am writing 1 by 4 pi epsilon naught. So Q2 Q naught by R2 square 1 by 4 pi epsilon naught. Q3 Q naught by R3 square 1 by 4 pi epsilon naught. Q4 Q naught by R4 square, like this we can write it. This is the sum. This is called superposition principle. Up to here complete చేసుకున్నామా? Yes, continuation. Superposition principle. For the two charges, if you choose about, there are two charges. Okay, is the first situation. First charge is Q1, next charge is what? Q2. Distance of separation is a distance of separation. This is what? R. Okay, how many charges do you have? There are two charges. So what is the force between these two? F is equals to, what is this? 1 by 4 pi epsilon naught Q1 Q2 by R square is what? Electrostatic force of attraction or repulsion. So if this is what? For the first relation, it's a case 1 I am talking on. This is a case 1. Next one as a case 2 second. Okay, case 2. So case 2 is, I am taking about, there is an x and y axis. I am choosing this. Okay, so like this. Okay, so this is what? It's x. Next one is y. I am choosing three charges. Three charges means one charge is at the center, another charge is on x axis, next charge is on y axis. It's what? The distance is, for example, 1 meter and 1 meter. Okay, let it be, it's what? 1 coulomb or 1 micro coulomb, anyone can. So I'm choosing about, this is what? 1 coulomb charge. It's a 2 coulomb charge. It's a 3 coulomb charge. My question is that find the net force. Okay, F net at 1 coulomb charge. Okay, so net force on 1 coulomb charge is my question here. Okay, so for the problem solving, such is very important relation here. If we talk about 1 coulomb and 2 coulomb, so between these two, so where you want to find it? Sir, between, yeah, which one is this? This, and next one this. Correct? Yes. So next one, these two. So 1 second. Now we check on this. So where you want to find on this? Between these two. Okay. Next one, between these two. Yes. First one, with at what charge this? With this one, how many pairs do you have? 2 pairs. 2 pairs means what? You will be having 2 forces. 2 forces. Both, what is the nature? Positive and positive. The force should be acted what? Away. Let it be, this force is what? F1. And next one, it's what? This is what? Between these two, repulsive, it's what? F2. It's a F2. Correct? So what is the angle between these two forces? 90 degrees. First let me know on this, what is F1? F1 is equals to 1 by 4 pi epsilon naught. I can also write K. Okay, 1 by 4 pi epsilon naught. Q1 Q2 means 1 into 2 by 1 square. It's what? K into 2. This is what? It's a 2K. And F2 if you write between these two. Okay, so what is this? K into, so Q1, Q2, 1 into 3 by what? 1 square will become as what you say, it's a 3K. Yes. So what is the net force between these two? F net is equals to, and the root of, what is this? F1 square plus F2 square plus 2 F1 F2 cos 90 degrees. What is the cos 90 value? 0. So this is under root of F1 square, it's a 2K square plus 3K square. So what's your answer? 2K square, 4K square plus 9K square. So 13K square would become as what? Root 13K is my answer. Yes. So this is just F1 and F2. Like F1 and F2 2 are there. For 3 are there. So vectorially we can add them. So vectorially means what? Angle comes into play. Okay. Not only magnitude, angle also we need to use it. So next one for the case 3. Okay. Case 3. Third one. But 3 charges. So I am choosing about an equilateral triangle. Yes. So equilateral triangle. Yes. 3 charges are placed at the corners of equilateral triangle. Yes. So the corners of equilateral triangle. Just if you choose about first charge here, like this. Next one. How many types of questions will be asking on this? Its side length is what? A. This is what side length is A. Yes. Equilateral triangle means what? The angle must be what you said, say 60 degrees. Yes. First question. What is the net force at centroid when a fourth charge is kept? When a fourth charge, let it be, it's a Q naught. Fourth charge is kept. What is the net force at its centroid? First question is net force. Okay. Net force at centroid. Okay. So centroid placed. What is the place charge? It's a Q naught. The charge is what? It's a Q naught. Now, so between with this, how many pairs do you have? How many pairs? 1, 2, 3. So how many forces you have? 3 forces. F net is equal to what you say? F1 bar plus F2 bar plus F3 bar. Okay. So first one, between these two, same, like it should be what? F1. Let it be. So between these two, what? It should be F2. Between these two, what is it? It's a away. It's a F2. Between these two, what is this? It's a F3. Correct? Yes. This distance is what? R. So you know already from this, R is equals to what? A by root 3. Distance from centroid to its vertex of an equilateral triangle. What is this? R is equals to A by root 3. First one, I am talking about what is F1. F1 is equals to K. Okay. Where is the F1? Between these two. What is this? Q into Q naught by R square. F2. Yes. Where is the F2? This. Then what is the same? Q into Q naught by R square. And F3. So it's what? K. Q into Q naught by it's a R square. See, all of these have same magnitude. Can I take it as it's a F? 3 of them. F1 is equals to F2 is equals to F3 is equals to F. Okay. So now let us see. Again, I am representing vectorially this. So first force is this. Next force is this. Next one is this. It's a F1. This is what? It's a F2. This is what? It's a F3. Yes. So what is the angle? It should be what? The angle is what? 120 degrees. 120, 120, 120. Total 360. Correct? 120. So I am finding resultant of these two. What is this? F23. F23 is equals to under root of, what is this? F2 square plus F3 square plus 2F2 F3 cos 120 degrees. Cos 120 minus 1 by 2. Yes. So this is equals to under root of f2 square means f square only. Next f square only. Next 2 into f square cos 120 minus 1 by 2. 2 cancel. Minus f square plus f square cancel. Square root of f square. What's your answer? F. Isn't it? So it's what? This is again redrawing from here. Here is what? F. F1 means what? F. The resultant of these two is what it say? F only. The angle between these two is what? 180 means what? Opposite direction. These two will be cancelled. What is the F net? F net is equals to 0. When a fourth charge is placed at its centroid, what is the net force at its centroid? Okay. When fourth charge is placed of an equilateral triangle, net force is equals to what? 0. Okay. So, next one. So, for example, from this, again situation I am taking on this. Here, this is what? Equilateral triangle, same as it is. Yes. So, here, like for this, how many charges I am placing here? 3 charges now. Yes. So, to execute electrostatic force, minimum 2 charges are required. I am asking, so again, same as usual, it's what? A. Yes. Find net force. Okay. Net force at any one corner. Okay. So, any one corner of, okay, any one corner, or find the net force at Q placed at any one corner of an equilateral triangle. Equilateral triangle. Yes. So, is the relation. So, what is the force? For example, I am taking as this is Q. It's a Q and next one is what? Q. Yes. So, or the question may be asking. Yes. Net force. Okay. At third charge. Okay. Is equals to what? What is the net force at the third charge? So, same where which I am talking on this. Sir, net force on the third charge. Third charge means what? This is the third charge. Let it be. This is third charge. With this charge, how many pairs do you have? How many pairs? First one and second. So, how many forces are possible? 2 forces are possible. Yes. So, the angle between these two is what? It's a 60 degrees. Between positive and positive should be away, repelled. So, what is this force? F1. Between these two, it's a away. What is this? F2. What is the angle? 60 degrees. Let me know what is F1. But F1 is equals to K. Q1, Q2, Q square by A square. F2 is equals to K. This Q1, Q2, Q square by A square. So, what is this? It's a F only now. Yes. So, what is the F net now? F net is equals to under root of vectorially. What is this? F1 square plus F2 square plus 2F1 F2 cos 60 degrees. Yes. So, this is what? F1 means what? It's a F square plus 2F square cos 60 is what you say? It's a 1 by 2. 2 and 2 cancel. F square plus F square plus F square. So, this will be what? It's a root 3F is my answer. Yes. So, net force at the third corner is what? That I can say this. F net is equals to, so root 3 times of F means what? K. Q square by what? It's a square. A is what? Side length, not distance from center. Distance from center means what? It's a R. R is equals to what? A by root 3. So, this is my answer. Sir, if I use this is what? Positive charge, positive charge, positive charge. If I place here, this is a negative charge, let it be. One is positive, next one is what? Negative. Any one corner is negative. Okay. So, let it be this. Next case, just possibilities I'm saying on this. Yeah, first one. So equilateral triangle, again same the situation. Yes, like so. First one, three charges as usual, but their nature I'm changing. This is what? It's a minus q. It's a q. This is q. Yes, its side length is what? A. Side length is what? Is it's a A. Yes. But first we need to find its what is this direction of force. First we need to find the direction of force. Where you want to find? I am asking this. What is the F net? F net is equals to what at this corner? Yes, these two like or unlike? Unlike. Unlike means what? Attracted or repulsive? Attracted. Attracted towards where? This. This is what? F1. Correct. So these two like or unlike? Unlike. Sorry, like means what happened? Repelled. Repelled means what? The force will be acting towards is this. What is this? F2. But this angle is what? 60 degrees. This angle must be what? 120 degrees. So again, my force is what? F net. F net is equals to, so then what do you say? F1 bar plus F2 bar vectorially. If you want to find its magnitude, F net is equals to, so this magnitude is equals to under root of, what is this? F1 square plus F2 square plus 2F1 F2 cos 120. Cos 120 minus 1 by 2. Yes. So this is what under root of. Now what is the F1? F1 and F2. So let me know about what is F1. F1 is what? K. Q into Q. Q square by A square. Don't write minus. Minus indicates only its direction. Okay. Magnitude. Electrostatic force is directly proportional to product of magnitudes of two charges, not minus plus. It's a magnitude. Even it is there minus also, you have to take it as plus only. Minus indicates only its direction. And next one, for the F2 is equals to also same K into Q square by A square. Yes. So both of these two what? It's a F only. F means what? F1 square, F square plus F square plus 2 F square minus 1 by 2. Same 120 degrees there means what? Same force always. So what is the answer? It's a F. F square plus F square, 2F square minus F square. So 2F square minus F square, F square. Square root of F square is what? It's a F. Yes. So what is the F net? Net force is equals to, now I am talking on this, F net. Net force is equals to F. F means what? K into Q square by A square is what? It's a net force is the situation. Okay. So this is about the three charges. Like any are there. So according to their nature, so the is it attractive or repulsive, you have to check it as, based on we can respond it. So for the three charges, so for example, net force, okay, so due to four charges, okay, four charges, I'm taking about all these are same magnitude. Different magnitudes also we can take it as, whose magnitude is bigger, it should be away from that one. Is okay. So first one, very first case I'm choosing as this. So this is okay. Yeah, like is the situation. Yes, I'm placing on this. Yeah, four charges. Four charges. First one this, next one, again this. Yes. So side length is what? A. Yes. Now I'm asking a question. So what is this? This charge is what? Q. It's a Q. Yes. What is the force at center when fifth charge is placed at its center? Okay. So my question is that find net force, okay, at Q naught placed at center. Okay. Center of a square. Center of a square is the question. This is the thing. First one, let me know on this. Again, what about the nature of force? Okay, so let us discuss on it. These two. So where you want to find? Here. Due to this on it, both are like or unlike? Like. Like means what? Repulsive. It should be towards. Due to this one, it should be towards. Due to this one, it should be towards. Due to these two, it should be what? Towards. Getting? So, now, do you know all the forces are same, correct? All the forces between these two, for example, if we take, the distance is what? R. R is equals to what? A by root 2. R is equals to A by root 2. Okay? So, now we can take it as R is equals to A by root 2. First one is F1 is equals to F2 is equals to F3 is equals to F4 is equal to, what is this? K Q naught by R square. K Q naught by R square. K Q naught by R square. Next one and next one. So what is the net force here? F. Yes. So this is that F. Now vectorial I am writing on this. This is what? F. Next one is F. Again is F. Next one is F. This 2 will be cancelled. This will be cancelled. What is the F net? F net is equals to 0. Net force at its center. When 4 equal charges of charge Q are placed at the corners of a square, net force is what? 0. Okay. So next one. If I ask the question at its any one of its corner. Okay. So next question is about find net force at any one corner. Any one corner. So where you want to discuss any one corner of what? Equilateral triangle. What is this? It's a square. It's a square of side length A. Yes. Again the same situation. So we should go for this. This is what? It's a square is taken. Okay. Of side length is A. Yes. Like is this. Now we can talk on it. It's a side length. This is what? A. Yes. Now the charges are placed here. These are the charges. It's a charge length is what? It's a Q. This is Q. Next Q. Again Q. Next Q. Yes. At what point? At this. Find the net force. What is net force? Is my question. Okay. So with this one, how many pairs do you have? 3 pairs. How many forces can exist? 3 forces. Okay. So for the first one I am talking on this. Yes. So between these two, for example, due to these two, same like or unlike, like, attracted or repelled, repelled means. Okay. Between these two, correct. If you want to extend, you can extend from here, no issue on this. Okay, so now 3 forces we have. So first one, let it be, this is F1, this is F2, this is what? F3. I want to add these 3. What is this? F net vectorially is equals to F1 bar plus F2 bar plus F3 bar. First one, we should add these 2. The resultant of 1 and 2 should be along with this. What is this? F12. First, let me know what is F12. Yes, F12 is equals to under root of, what is this? It's a magnitude. I am writing this. F1 square plus F2 square plus 2F1 F2 cos theta. Where is F1? This. Where is F2? This. What is the angle? 90. So this is what? 90 degrees. 90 degrees means what? 0. So this will be what you say, under root of F square plus F square plus 2F square cos 90, 0. So what is the answer now? 2F square. What is the answer? Root 2F. This is what? F12. Okay, because F1 and F2 have same magnitude. So what is the F1? F1 is equals to K Q into Q square by A square. F2 K Q square by A square. That's what I'm taking as F. In place of F1 F, in place of F2 also F substituted, because this same. And so what is the length from here to here? It's a root 2A, correct? Yes, this is A, this is A, this become what? Root 2A, diagonal. Okay, so I want to find about F3. How should I find this F3? My F3 is equals, what is this? K, Q into Q square. A means what? What is the total length? Root 2A whole square. What happens now? K Q square by 2A square. Okay, this is what? 1 by 2 times of K Q square by A square, correct? What is K Q square by A square? F. So this is what? It's a F by 2, correct? So what is the net force now? F net is equals to, what is this? F3 plus F12. My F3 is what? What is the F3? This. What is this? F by 2. F12 is what? Root 2F. So what is the answer? F times of root 2 plus 1 by 2 is my answer. What is the F? What is the F again? F is what? K Q square by what? It's a square. Root 2 plus 1 by 2 times of K Q square by A square is a superposition. Find the net force at the point B. The charge which is placed on the point B. Here is the question. So the question is, first one, at this point, I am asking to find the net force at the point Q, at the point B. First, we said you that it's attraction or repulsion. First one, these two are what? Like charges. Like charges means what? Repelled. This acts a force on this. What is this? Here, first one, let it be F1. Repulsive force due to this on it is what? F1. Due to this on it, both will be what? What is a repulsive. So this force is what? It's a F2. This is 60, means this will be what? 60 only. So first we need to find F1. What is F1? F1 is equals to, F1 comes from where? From these two, right? So then what? K Q1 Q2 by R square. What is the K? K only, let it be. Okay. And Q1 Q2 Q square by R square. Next one, F2. F2 is equals to K. Then what is this? Q1 Q2 means what is it? Say Q square by R square. Same as the thing is what? KQ square by R square. So what is that? Let it be, its force is what? F. Now two vectors are acting from the same point. That's what? Net force is equals to square root of, what is this? It's a F1 square plus F2 square plus 2 F1 F2 cos 60 degrees. Okay, cos 60 value 1 by 2 is equals to under root of F square plus 2F square cos 60 is 1 by 2, 2 cancel, square root of 3f square will be what? Root 3f is your answer. Okay, so what is the f? F is what? Kq square by r square. So f net is equals to k. So this is what? Q square by r square times of what? It's a root 3 is your final answer. Anyone, either we can use this or this one according to given option. This is also, this is pith ball model. Okay, pith ball model problems. Yes, say pith ball model problems. So pith ball means what? When a ball of mass and its charge is given. Okay, so this type of questions will be asking. And equilibrium of suspended point system. So this equilibrium, it's a equilibrium of suspended point system. Okay, so point system. Okay, so point system like this. Also these are the models. So just I'm giving very first case. So just I'm taking on this is a fixed support. Here is a fixed support. Okay, so two balls are suspended. Yes, two balls are suspended. These are the two balls of the same length. The strings are having what? It's a same length. Okay, same length strings. Okay, so these are what you say uncharged balls. Okay, uncharged balls. So these uncharged balls means, yeah, like a pith balls. So I given some charge to them. Some charge means what? If I give the positive charge to for the both of them, then what do you say? This is, so now it become as, this is what? Vertical. Correct. So what distance the ball can rising from this position, if I take as this is the position. Okay, so with the same angle another ball also comes back with this same angle. So this is what? Here is one ball, so this is what? Another, right? So like if you choose on this, and next one, what is the distance of separation? Distance of separation is what? For example, this is x and this one is x. This I'm taking as what is it? It's a 2x is the distance of separation. Yes, two strings are there. So there is what? It's an angular separation. This is theta. This one also theta. So this makes an angle is what? Sorry, it's what is this in the tension? It's what? Tension is what? T. That's it. Now I'm going to that. So in the situation again, you see this. First one, two balls are given. For these two balls, so uncharged one, whenever charge is given, yes, some charge is given to this. So the charge is distributed. Then they should get what? Repel to each other. So they should repel to each other. Then repelled and separated by a distance, angular separation. So theta plus t theta is what? 2 theta. So with the vertical, with this is making an angle theta. Next one also making angle same theta only. My question is that why they are separated? What forces are balanced when the system is in equilibrium? System is in equilibrium like this, they came and remained rest. Okay, so what forces are acting on this? So this is what? First one is what? Tension T. Well, you can say this is what you say, it's a mg. For the first one I'm talking on this, any one ball I'm choosing on this, its weight is what? Mg. Yes, so this is what? Tension. Okay, so tension is here, tension T is resolved into two components. This is what? Tension T. Yes, resolved into two components, either sides for the both the cases, right? So now, yeah, when you are talking about this makes an angle theta, means this one also making an angle theta only. Yes, so this is what? T. So whenever adjacent comes into what is it? It's a cos function. This is what? T cos theta. This is what? It's a T sin theta. So T cos theta. Next one is what? T sin theta. Okay. So its weight is what? mg. Its weight is mg. Just a minute. Sir, good morning, sir. ఈరోజు ఎగ్జాము లేదు, ఒకవేళ మీకు ఛాన్సెస్ ఉంటే సరేమని. అయితే యాక్చువల్గా వాళ్ళు ఓన్లీ సాటర్డే రాస్తుంటున్నారు. 2 days అదే వచ్చిరా మీరు? ఓకే ఓకే సరేలేండి. ఓకేలేండి పర్లేదు. సరేలేండి ఓకే. Yes. So now these two, both of them are having the same charges. Same charge is what? It's a Q and Q if I choose it as. Okay. This is a charge Q. Next one also Q. So between these two is what? Electrostatic force is there. That electrostatic force acts what? Like this. This is what? Electrostatic force. Correct? Electrostatic force is balanced by what? T sin theta. T cos theta is balanced by what? mg. So this is what? It's a tension is what? It's a T. Okay. It's what? Tension is what? T. Then for the first condition here, so T cos theta. T cos theta is balanced by what? It's a mg. And the second one is that, so T sin theta. T sin theta is balanced by what? Fe. For your kind information, so what is the electrostatic force? Electrostatic force means what? Fe only, no? Fe is equals to what? K q square by r square. So Fe is equals to K q1 q2 by r square. So the what is the r here? X plus x, 2x. 2x whole square, 4x square. Okay. So just I'm making as, this is my first and second condition. From these two equations, what do you say? T sin theta by T cos theta is equals to Fe by mg. Okay. T and T cancel. What do you talk on this? Tan theta. Tan theta is equals to what? Fe by mg. My Fe is equals to what do you talk on this? Mg tan theta. Okay. Is your primary information. Fe is equals to what? Mg tan theta. Fe should be what? Electrostatic force. Okay. So that electrostatic force, I'm talking on this. Fe is equals to mg tan theta. Fe means what? Fe, electrostatic force, K q1 q2 by r square. What is the q1 here? Q1 is what? It's a q. This one also q. This is what it's a 2x. X plus x is what? It's a 2x. So now I'm talking on this. Fe means what? K q square by what is this? 4x square is equals to mg tan theta. Is the situation like this model questions will be asking. He may ask us what is the distance of separation between the two balls. Okay. He may ask us what is the angle made tan theta with vertical. Okay. So you should take care about this one. Angle between two. Okay. Two positions. Theta plus theta is what? 2 theta. With vertical is what? Only theta. So he may ask us what is the q. Q means what? If he is asking about to find the q. Okay. So this is what? To find q. Yes. To find the q. To find the q is what? Q square is equals to mg tan theta into 4x square by what? It's a k. Then q is equals to square root of mg tan theta into 4x square by what? It's a k is the relation. Okay. Like this. So this is what just is talking about what you say, just what is the charge is distributed on the spheres or on the balls. And again I'm talking, so this is what tension. Vectorially I'm talking. It's a tension. Yes. So this is what its weight is, what you say? mg. Correct. This is what it's a fe. Correct. This only, you know, from the ball. This is what you say, it's a vertical. Correct, ma? It makes an angle is what? Theta. Am I right? Yes. So this is your ball, pith ball like or charged body. It's a charged body. Yes. So now I can talk on this. This is the resultant of these two is you take about. Resultant, how should you take about resultant of this? Parallel to this, draw a vector. Parallel to this, draw another vector. Yes, this gives what? It's a resultant. So resultant is balanced by what? T only, you know. T is what? Tensional force. Correct. So this is what? Resultant. So then T is equals to so under root of Fe square plus mg square is my case. This is what? T is equals to Fe square plus mg square. T is equals to Fe I cap, mg downwards minus j cap. If you want to write, this makes an angle theta. So this one also what? Theta. Yes, vectorially if you write, T bar is equals to Fe, it's what? I cap, okay, plus next one is mg downwards. What is this? It's a minus j cap. So its magnitude. Magnitude means what? Under root of Fe square plus mg square is the situation. This is what it shows. It's a directions only. Okay, like. Next one is the concept of equilibrium. Concept of equilibrium. Yes. So what do you mean by equilibrium position? So for the equilibrium conditions, for equilibrium, just one second.